DP. Okay. You are from? Then why you came? Just for 2 months. Oh, great. See guys, dedication. స్టూడెంట్ బెంగళూరు నుంచి వచ్చి క్లాసులు వింటున్నారు, మనమేమో హాస్టల్లో ఉండి కూడా రాము. Whoever there near to Naresh IT, see the dedication, that's what. ఏంటి? Okay. Let's get started now. I have two big things today, Veera. Thanks. Tell me immediately. We don't have time. We need to jump. Till here clear, right? My research and something my day. Okay, great. All the best. Congratulations. Till here clear, right? The process, how it will work and all. So what I'm going to do now, this is the process. Oh, then how you can say okay? Great. So now, end-to-end flow, you are clear, right? End-to-end flow, you are clear, right? So now, we can go to a deep dive how control node, worker node will work now. Okay? So remember this process. I'm taking now this process only today. Okay? A very important. So guys, let me start the process. Yeah, let me start the process. So Kubernetes or K8s also, we can say K8s or Kubernetes. So in general Kubernetes guys, we have a different process are there. I mean COPS process. COPS process, cloud managed Kubernetes. So the difference is, the only difference is control node. We have a two type of nodes, right? Control node, worker. So cloud managed Kubernetes means AWS EKS means Elastic Kubernetes Service. Every day is a very important. Every message is very important from today, my end, into the Telegram group. So to understand these concepts are not at all easy. Every message, every content, every word is very important here to understand Kubernetes. It's not easy to, it's an art to learn Kubernetes. Okay. Next. AWS EKS. Next. Azure AKS. Same. Azure Kubernetes Service. And next, GKE. Google Cloud, GKE. Google Kubernetes Engine. Okay, each cloud providing a dedicated Kubernetes service. Okay, now guys, Kubernetes is a third-party process, third-party open source process, not from any cloud background. But what these clouds are doing now, Kubernetes on Amazon, Kubernetes on Azure, Kubernetes on Google, they're build a platform like this. Understand? Still, EKS is a Amazon managed Kubernetes. Azure also Azure managed Kubernetes. Google Cloud is Google managed Kubernetes. Understand the difference? But always Kubernetes is a open source third party tool. But the tool on this cloud, the tool on Azure, the tool on Google Cloud only. This is not fully managed by AWS Cloud or Azure or GCP. Partially managed. Partially managed means that these three clouds responsibility for only the node, control node. Understand? These three clouds will take care of control node responsibility. Control node high availability, everything managed by these three clouds. Clear now? What about worker node? User has to take care. User can take care. Worker node. User means not end user. Who can develop or developer something? Worker node. Clear now? So we have a two type of nodes in Kubernetes, right? What are those? Control node, worker node. So cloud responsibility for what? Only control node. Worker node we can take care. Clear now? I mean RDS is there, right? RDS instance, we don't know where it's created, right? But we got access already. Here also, control node, we don't know where exactly created in the region, but we will get access. We can see only worker nodes. Only worker nodes. Okay. What about COPS process? Guys, COPS process means here, yeah. COPS process means control node, worker node, we have to take care. No cloud will be take care. Both responsibilities, control node and worker node, we have to take care. Okay. One more process is their kubeadm process. We are not using at all, already deprecated. So 99% organizations are using this process only. Cloud manager Kubernetes only. Maybe 1% are using COPS, but they are also still moving to cloud manager Kubernetes. Not fully managed, partially managed. And this is what? Orchestration tool, right? Kubernetes is a orchestration tool. So cloud manager Kubernetes will take care of only control node, not manager node. That the reason this is not a AWS service, Kubernetes is. They're just giving a wrapper. We will also take care of Kubernetes. We are giving a one wrapper. The wrapper is called cloud manager Kubernetes. So worker node you can take care, control node we can take care, like that. But cloud managed orchestration tools also there. Complete managed. Give me an example. Very good. Complete cloud managed orchestration tool is ECS. Already I took a workshop, right? Right or not? Today your job is to look on it. At least. What is ECS? Okay. ECS. Complete cloud managed orchestration. This is native tool, AWS native tool, not Kubernetes. But what is the difference between ECS and Kubernetes? The main difference is ECS is not suitable for a large applications, large configurations. We don't have a, a custom configurations. Completely managed by cloud means what? We don't have any customizing actions on this. We can like plug and play kind of things only. So we don't have a custom actions to perform anything, the required actions on ECS like AWS Lambda. Okay, just you tell me AWS Lambda, the background, which DevOps process will work? Docker file, no. Docker file you have written, right? Sleep represents what? Sleep. In the Docker file, echo, we have given echo high sleep 150. Means what? 150 seconds. This continuously run. After that, what? Stop. So Lambda background also Docker will work. Once you create a Lambda function means what? You are creating one environment. Upload code means copy the code in the Docker file. Deploy means build a image. Test means run a container. Container runtime 15 minutes is the highest time. After 15 minutes, automatically deleted your container. Kill the container. Understand? The AWS Lambda background Docker process will work. Okay. Yeah, internally we don't have access to do that. Internally they're implementing that. Lambda, we have a deploy process, right? Deploy code. Upload a code means copy the code. And from image means what? In the Lambda, from image instruction is there in the Docker, right? In the Lambda, from image means what? You are selecting a runtime, right? Lambda runtime, Python or Node.js or Java means from Python, from Node.js, from .NET, like that. After that, from, we need to give code, right? Copy the code means what? Upload a code. The runtime you can select until what time. After the deploy means what? Build this process. Test means run this process. So run max time of the container 15 minutes the design. This is the process. So why there Lambda is a very cheap? Why? We can pay for running cost only. Container runtime only we can pay. After container kill, we no need to pay, right? That's what. But EC2, whether process is running or not, EC2 continuously running or not until you terminate. So we have to pay. So continuous running process go for EC2. Temporary running process go for Lambda. In AWS, same process we can implement Kubernetes Docker already. Right or not? Okay. And now guys, worker nodes means what? No, worker nodes means what in AWS? EC2 instances are right. So now ECS with instances you can, ECS worker load means here you can take a servers. Same, EKS worker loads also servers only, right? ECS, EKS. What is the difference? ECS completely managed orchestration tool, AWS native tool. EKS means what? Kubernetes service on AWS. Okay, but this Kubernetes service is not AWS own tool. It's a partial wrapper. We are giving a support also like that. So in this case, EKS we have a control node, and next is what? These are what? Worker nodes. Very good. So these are the worker nodes, these are the worker nodes. But engine is what? This is EKS engine, this is ECS engine. ECS engine is cloud managed engine, so they will take care. EKS is a just wrapper on cloud, so they will take care of control node only. Now again we have a, so for example EC2 if you can take now, this EC2 who can take care of? You can take care of. Still we have different options. We can take a Fargate. instead of taking worker nodes. Fargate means what here? Serverless resources without EC2. So you can take Fargate or instance. That's what I'm saying. Attend my workshops, huh? You won't listen at the time. Now you are saying everything is new. Huh? Yeah. 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 Not runtime, it's continuously run. Not based on the runtime. But the required resources, it will take care. Oh. You will get a clarity. Wait. Hmm. Simple understanding is here. Fargate is a EC2, but serverless EC2. Serverless EC2. Then what is the difference between EC2 and Fargate? If it is a EC2, no, you need to take care the EC2 high availability, EC2 work. I mean, for example, this EC2 resource is a limit, right? Limited resources. But Fargate, no limit. For example, your end 100 containers are running. Here 100 containers are running. Here 100 containers are running. Now no space to create 101 container. What will happen? Tell me. Huh? 100 containers are running. Full EC2 resources are you are using. RAM and hard disk and CPU. I want one more container. What we can do? What options we have? Oh, okay. I'm not asking how it is creating. What we need, I'm asking. Create a one more server. Worker nodes, minimum 2, max your wish. Third worker node is required or not? Third worker node also full container, I mean pods are running full. No pod is creating. Now fourth worker node is required. Worker nodes we can increase, stretch when the pod requirement will come. Now 1 lakh pods I need. Worker nodes I should increase or not to place the 1 lakh pods. But these EC2s who can take care? You can take care. Worker node is in your responsibility. So auto scaling, you have to take care. Scalability, you have to take care. But if you take a EKS combination, EKS with far gateway combination, you no need to worry about that. Whatever resource is required, Fargate will give. Fargate will give. Understand? You no need to worry about my EC2 are enough to host on these resources and all. It's not like that. This will take care always. Clear now? So, not required in auto scaling now. Required resources, Fargate unlimited resources will give to your application always. From where? Fargate is a serverless service. They will take care. They will take whatever CPU, RAM required, it will give always. Clear now? Same concept here also there. Everything is YAML file. ECS also YAML file. This is also YAML file. Same ECS combination also. We need to write. We need to write everything. Clear the difference? But when we can use ECS, when we can use EKS, I have already given in the workshop in clear explanation. Based on the application size. I need a 100 applications. ECS is not support. So ECS is a limited actions only it will support, not unlimited. So if you need a well orchestration, if you need a well support, if you need a bulk configure required the background, if you need a managed some custom configurations, go for EKS combination, not ECS combination. Clear? So we'll see this area later. Later means depends on your work. So I have already done workshop. Try to understand, video also available on YouTube. Try to understand and raise a questions from that workshop. Simply watching and follow the step by step blindly, not a good idea. I have seen the today workshop in ECS Fargate. Then guys, what is the difference? Like the questions you can raise from your end into the group. You can see the number of solutions. Understand? So from now onwards, if the group is silence means no use to learn this. One person can't understand 100% here. Number of persons can add and give clarity day by day. Only work out here. Understand? So everything in your hands only now. If you are always silence, Docker Kubernetes, Kubernetes concept also silence only. If some until ask someone one question from the Kubernetes, you don't know the value of Kubernetes. If you attend any, I think you can check with seniors. Whoever given interest, may they can understand the questions will come from Docker and Kubernetes is 40%, 30% Terraform, remaining cloud, Jenkins and cloud. This is a very important area. All, yeah, it's correct. If you need across region high availability, we need to create 2 clusters. Anyway, so this process, we can see later COPS process. What is the difference between COPS and EKS or AKS? COPS, control node, worker node, we can take care. EKS, AKS, GKE, control node, they will take care. Worker node, we can take care. Clear now? Okay. Both are automations, but in terms of automation also, there is some differences. That's what I'm saying. One person can't justify this entire process. Multiple team can involve here and clear your doubts. Clear your doubts. Finally, one answer will write. That answer everyone can understand. Understand? Huh? Yeah. COPS process you can deploy in on-premises or cloud. Understand? COPS process, I need a servers only. Either on-prem or same process you can deploy in cloud. But if you deploy in cloud also, cloud is not responsibility for your control node and worker node, like DB and EC2. This is DB and EC2, this is RDS. Everything, see, COPS process, everything 0 to 100 you can take care. Cloud manager Kubernetes process, you can take care 50%, they can take care 50%. Understand? That 50% also I don't want to take. Then go for EKS Fargate. Fargate is also serverless, means cloud managed. Control node also, they're managed. So everything AWS managed, mostly. Yeah, worker nodes means Fargate, right? Fargate means what? Serverless, right? Serverless means what? Nodes are in their end, means they will take care, right? So fully managed Kubernetes, if you want, go with EKS plus Fargate. You may get it out. In this case, we have a ECS Fargate Navira. Then why we need to go for higher configurations, EKS. Okay? You will get a clarity not now. Lot of things need to discuss. Shall we start? How many nodes are there in Kubernetes? Yes, this is one entry question, 100% one entry question from this architecture. 100%, even if you are from 15 years background also, 15 years experience in IT also, one entry question from this architecture. And once again, I'm saying that this architecture, you won't get clarity 100% today itself. Every day you will get a clarity. But still, I'm trying to give a best here to make you understand the concept. How many nodes are there? 2 nodes. One is control node. And next is what? Worker node. Clear now? Okay. Control node response will come from where? AML file, right or not? Control node response come from where? AML file. AML file means your requirements. Half an hour focus here. Please don't ask share interview questions. Video is recording or not? Okay. So if you apply AML file, request will go to where? You know, control node. But where in control node? Now I'm going to start explanation. Okay. So guys, we have a number of components in Kubernetes. The components are, the components are, let's wait guys, I got some message. Yeah, okay. A very important components in control nodes are, first, API controller. You don't write anything. I will give a nodes. Just focus only. Let me write a big one. Control node. Okay, guys. Inside control node, the first very important component is API. Okay, API controller. So the first request will go to from your instructions to API. Okay, I mean, in the Docker, the first request will go to where, guys? Docker daemon. If you run any instructions, Docker pull, Docker push, the request will go to Docker daemon. Docker daemon will take the responsibility of the what next and all. Here also, like a API server, like a Docker daemon. So this is API server. I mean, API process will run inside the control node. Clear now? So my YAML file request is create a pod. It's just an example. You know, right? What is pod now? What is pod? A additional layer of container to manage the Kubernetes. If you create a pod, I need what? Request to create a pod. My request is to create a pod. First request will go to API. Guys, pod will land on which node? Control node or worker node? Huh? Worker node. Pod will create in worker node. In this case, my request has to execute here only, right? My request has to execute here only. So now, my end, two worker nodes are there, for example. Clear now? Two worker nodes are there. So definitely my pod, if single pod means the pod can create here or here. Clear? We have a two options. Okay. So in this case, there is a concept, there is a one more component is scheduler. Okay. This component will take care of to schedule a pod on node, suitable node. Scheduler by default, scheduler by default, assign any node to deploy this pod based on resource availability. Understand? Same load balancer. Based on the traffic, redirecting request into available instance. Here also this worker node is busy, for example, with existing pods 90% occupied. This is only 50% occupied. Scheduler choice is this worker node. What is scheduler? Scheduler schedule a pod on suitable node based on the resources. That's it. I will give the statements and all. You don't worry. Now, okay, API for example, give a request to scheduler. I got a request from developer. Developer means anyone who can create a pod. I need to create a pod now. We need to create a pod now. Give the suitable node. So scheduler will give, for example, this worker node. So pod will land on this node. But we don't know this is new pod or deleted pod. Understand what I'm trying to say? This pod may be deleted before and creating again. Understand what I'm trying to say? This is not a fresh requirement. Maybe this is not a fresh requirement. The requirement will go to API. Pod is deleted, create again one more pod immediately. It's an old requirement only, right? In this case, this is new requirement or old requirement. To check in control node, we have a etcd component. Okay, etcd component. So etcd work like a etcd component is kind of database. Okay, no SQL database. So this etcd etcd, okay, we are saying calling etcd or etcd. Etcd responsible, guys, maintaining the configurations like a Terraform state file. Same like a Terraform state file. Okay. Always etcd stores the configuration details of pod on which node, pod on created which image, everything, only configurations, not data, guys, not store any database data, only configuration details. My pod is running a second node, my pod is running a first node, and what under configurations only. In this case, API first asks to etcd, not scheduler, right or not? So I got a requirement to create a pod. Do you have any information respective of this AML pod? Etcd will back, yes, this pod before already configured. My end, I'm able to see the configurations. You can good to go. Same configurations means what? Same node. Understand? In this case, again API inform to scheduler. Pod is, I got a request to create a pod. etcd confirmed that the pod is before running on worker node, may be deleted, so that again request is coming. Should I go for worker node 1? Scheduler will give back to response, yes, go ahead as per etcd. Or no, all pods already running in the worker node. It's a busy. Go for next node. Like that, scheduler will get informed to API. Again, API will update to etcd. Okay. Scheduler also confirmed that the pod we are going to create on as per before configurations. Clear now? Second scenario. Whenever you will get a request to create a pod, the request will go to API. When API will check with etcd, if etcd will give information, I don't have any information regarding this pod, means what? This is fresh requirement, right or not? Okay. Immediately API will ask to scheduler, request to create a pod. Which node is better? Scheduler will give information back to API, node 1 or node 2. Immediately API will again inform to etcd, right? Configuration need to be stored, right? This is fresh pod means next time this pod may delete means etcd will give information back to yes, this pod is running on node 1. So immediately API will give inform to etcd. So as you said, no information you are in, right? Now I'll check with scheduler. Scheduler is already confirmed to create an worker node 1. So keep it with you this information to etcd. Clear now configuration now? You no need to do anything. This will be manageable everything in the background. Just I'm saying how to work around. Okay. Now as per the scheduler is decided worker node 1 or worker node 2, right? Now API will give information to worker node. Okay. So worker node also one more controller is there. The responsibility for worker node it will take. The controller is kubelet. This kubelet is the responsible to take care of all worker node components. Here API server is responsibility to take care of all control node components. Here kubelet is a control node of worker node. Understand like this. Now API will give information to, so we got a request to create a pod. Scheduler is decided to schedule on worker node 1. Okay. Now kubelet will run now container runtime, means container engine. So this kubelet will give information to container runtime. This container runtime create a pod. Understand? If you run your this container runtime by you Docker run, container will create. But this container is running by kubelet, means Kubernetes engine. So pod will create. Understand? So pod will create. No. So guys, a very important thing is no service will communicate one-to-one without API. API is the component to communicate one-to-one. I mean, this is not possible. This is not possible. See, all components will talk to other component through API only. API is a central management here. So scheduler is not possible to talk to kubelet. No components will talk one-to-one without API, not possible. If API will ask something, that component will give back to API again. Again, API will ask to something different component, that component will back to that same API again. Like that it will work. Okay. This is container engine or container runtime. You can take anything. Clear now? Clear now what I'm trying to say? Still, you don't worry. I'm here. How to explain and all the next level. Now guys, let's go to again the concept. Whenever request will come from the developer to create a pod, whether it is a fresh pod or old pod, which component will decide? etcd. Why? Etcd stores the configuration information of the pods and nodes. Right? Yeah. So if etcd is not giving any information to API means this requirement is fresh requirement. Clear now? Fresh requirement means the next request will go to where? Scheduler. Scheduler will confirm, okay, based on the resource availability, deploy this pod on any node. Clear or not? And this information give back to API only scheduler. Okay, hey API, you can create a pod on worker node 1. Okay. That's what I'm saying that, right? scheduler always monitoring the worker node resources. Based on the resource availability only, scheduler will decide. For example, 99% load is there here. Here only 1% load is there. Scheduler default action is to worker node 2 based on the resource availability. That's what I'm saying, right? But this scheduler, yeah. So this scheduler request will give back to API, and the API will again give request back to etcd again. Etcd had no information right before. So scheduler is decided this pod has to run on worker node 1. Keep this information with you now. Okay. Etcd again give back to okay. Now API will, so this control node concept is clear, right? We know the process. I mean, we know the information where we need to deploy this pod. Next, API will inform to kubelet. So we got a requirement. Scheduler already confirmed to worker node 1 only. Create a one pod. Kubelet take the response. Okay. Run a container engine. Whenever you can run a container engine, container will create, right? But here pod will create because of this is Kubernetes wrapper. So pod will create. Clear now? This pod same, that's what, same pod. Pod means what here? A layer, right? Pod inside is what? Pod inside. Container. Container inside. Application comes from image. No difference. It's a Docker only. Here, whenever you can install a Kubernetes, na, the background Docker will install. Automatically this is, you no need to do anything. You no need to install any Docker and all now. Now new version Kubernetes using container D, not a Docker. I mean, we have alternate tools, but container D also Docker only, Docker family only. Understand? I mean, once you create a Kubernetes pods, if you give Docker PS, you are unable to see any container. The reason, based on the engine, you can see. If they're using container D, different command, not Docker PS. I will show anyway. Clear till here? Okay. So now we have a one more service here. Okay. We have a one more service, kubeproxy. This kubeproxy help to give access this pod to external. I can say service, load balancer or any service. Pod is created, okay, but how pod will communicate external? Based on this service. Oh no, Route 53. Load balancer is a service or server? That service it will take care by kubeproxy. Now this kubeproxy will take care to give access to external world. Or you can give external world. Yeah, worker node only. So these users can access this pod through service. Understand? Which type of service? Node port or load balancer. In container also, we are going to give localhost port number, right? Exposing. Same process will work. Anyway, at this time, you just understand kubeproxy will help to give a service access to external only. Don't think much. Which service and all. I'll take care of the regular classes. Kubernetes. Hmm. Guys, you tell me if scheduler will give the info for worker node 2, not worker node 1, same process will execute or not? In this case, same process will execute or not? Clear now? So kubelet and these and all, each node one kubelet is there, engine is there, everything is there. Now API is, but control node is only one. Now API will give information to this kubelet worker node based on the request given by scheduler. Clear now till here? We have a one more component, the last component. Okay, the last component is controller. Controller. Very important now. Controller responsibility is, so controller responsibility is controller responsibility is if I created two replicas, means how many pods will create? Two pods will create. Controller responsibility is maintain the desired state, current state, like a state file. For example, if any pod will delete, immediately request will go to kubelet. Kubelet will give information to API. API will give information to first controller. Understand? Hey, pod is deleted. Controller immediately maintain the desired state, current state. So immediately controller will give information to API. Create one more pod immediately, same place. Understand? So in this case, two pods, one pod delete means whenever notification you will get from the API, controller will run the process again to maintain the desired state and current state. Otherwise, if pod deleted means, the API only the responsibility to take the information only. API can't do anything. Only take the information and give information. Give the information, take the pass the information only. But here controller will take care to maintain the desired state and current state. Understand? Okay. For example, yeah, this pod is deleted. Immediately, fraction of seconds, one more pod will create here. Same place. That will take care by controller. Clear now? So, how many pods? Controller is the only the responsible component here to maintain replica. If you give replica 2 in the YAML file, it has to maintain 2 pods always. One pod deleted, immediately get notification from the kubelet API, pod is deleted. Immediately controller will execute this YAML file to maintain the same state. Clear? So now, if you run same YAML file multiple times, any new pods will create or already pod is running status you will get. For example, I have executed now this YAML file. two pods are created. Again, I have given same command again, one more time. Again, two more pods will create. Our pods are already running state. Yes, you will get no changes. Response means what? The background controller etcd will play a role. When you run one more time now, API will ask to etcd get a response. No, this pod's already running. Configuration stored my end already. And check with controller. No, current state decided both are equal. Ignore it. The request is like that. It will work. Clear? Now, let's write a steps now. How the request will travel. Let me show you the PPT. Okay, better. So you may get a better clarity also. Kubernetes. This is clear? Architecture now. etcd, control manager, API server, scheduler. All are interacting through API server only. Next is what? Kubelet, Docker engine, proxy, user. IP tables means proxy part of the IP tables are a part of the service proxy. There is no separate component anyway. So now kubectl means we can run AML file by using kubectl command. That's what kubectl command here. Focus now. What is API server? When you interact with your Kubernetes cluster using kubectl command line interface, you are actually communicating with API server. Okay, when you run any command, the request will go to first API server. So before that, let's go here. API, these are all control components and worker node components. API server, etcd, scheduler, kubelet, run engine, Docker runtime engine. First time, if you create a pod, request will go to where? API server. API server write this information to where? etcd. etcd will give information back to, yeah. So no information means what? New pod. In this case, request will go to where again? Scheduler. Scheduler will give back information to API server. See, bind pod means decided pod is going to be bind on which node. Now API server will give information again to etcd. Your information is not there, right? Now scheduler is decided this pod is going to be bind on worker node 1. Keep with you this information. Next time if something is wrong, I will ask you, you can give the information back to me. Okay. Now again, okay. Next is, okay, etcd information is shared, right? Next, the API server will give information to kubelet. Decided, right? Which pod here? Now kubelet will run a Docker run. Whenever you can run, pod will create. See, kubelet will update the pod status to API server. Created. Yes, as you said, pod created. Again, API server informed to etcd pod scheduled on worker node 1. You are a configuration tool process you are going to be managed, right? You can keep with you this information. Pod is running on node 1. Like that. Clear the concept now? Let's go to here again. Yeah. So I'm writing a number now. First request will go to API. Next request will go to etcd. Next request will go to scheduler. Next request will go to, I'm not explaining again back response. Back response means one API means again information will come back to API, right? I'm not explaining that back response. So response already got back and again sent to scheduler, third. And next, okay, scheduler decided, control manager is decided. Sorry, not control manager. Scheduler is decided and again request go to etcd, right? Fourth time. This information is what here? Your and nothing is there. Scheduler is decided to schedule this pod on worker node 1. Okay. Now again API will inform to kubelet 5. Kubelet will run container engine. So pod will create. Again kubelet will take the response from the pod status and kubelet will give information to API. Created a pod. API will give again information to etcd created pod. And API will give information to controller also. Yes, created pods. Now control manager process is what? To monitor, watch the desired state, current state. Clear the process? Okay. Let me write now. First request will go to where? API server. API server to request will go to where? etcd. etcd to request will go to where? Again API server, right? API server to request will go to where? Scheduler. Scheduler to request will go to where? etcd. etcd to request will go to where again? Sorry, scheduler to API server. Again API server to etcd. Decided right already. etcd to again API server. Again API server to okay. First one is what? Let me change the color for easily understanding. Yeah. First one is what? API server to etcd. Again etcd to API server. Again API server to scheduler. Scheduler to again API server. Again etcd. Again API server. Again is what now here? Kubelet. Right? Kubelet to container engine. Container runtime or container engine to pod. Next, pod status to kubelet. Kubelet to API server. API server to etcd first. Delete created. Again etcd to API server. Again API server to controller. After that, again API server. API server to update to user created pod. Clear now? No questions to you. So now this process, yeah, I'll share the paint notes. You no need to configure anything. Just understand the how process will work. This is background running process I have explained. You no need to do anything controller configurations. You no need to do any scheduler configuration. This is by default communication taking care with the background nodes. Now go to ChatGPT. Yeah, worker node is only our responsibility. If in my EKS cluster, okay, in my EKS cluster, one pod is deleted from my node. Here, how the process will initiate step by step to create a new pod. Yeah, a pod is deleted manually or due to other reason. Kubernetes continuously monitor the state of resource using it's a control plane kube controller manager. API Kubernetes continuously monitor means API continuously monitor with reference of what? Control manager, desired state and current state. If delete part of deployment or stateful set, okay, the control managing it will notice the number of replicas has decreased. Example, if the deployment set to run 3 replicas and one pod is deleted, only 2 remains, controller will trigger. That's what I have explained. To associate, create a new pod object to match the desired state. Clear now? And now the kube scheduler, the new pod gets new ID anyway. And the kube scheduler checks the appropriate worker node based on resource availability. And this information I will discuss in the coming classes. So the kubelet on the schedule, select a worker node, receives from the node new pod specification to pull the container image and start the controller container inside and make it ready the pod. So if the pod is deleted, which component is working immediately? Control manager. API, Kubernetes will always monitor desired state and current state. If something is wrong, immediately request will go to controller. Controller will understand this pod is created through which YAML file. It will run again and maintain the desired state and current state. Clear? 2 replicas are there. If you run one pod is already created, one more pod only created. Not 2 more pods again created. Already one pod is created, running. Understand? This is a process. Then, what is the use of etcd here? Etcd is the brain of Kubernetes cluster. Brain means what? Store the information, right? You don't use a brain and heart and liver and all. This is just only, they are saying in interview, etcd is the brain of Kubernetes. Kubelet is liver of Kubernetes. IC is scheduler. Huh? Don't say like that. Huh? Okay. How etcd is used in the prod creation process? Huh? The deployment replica set. When you apply YAML file, the replicas are 3. This information stored in etcd. 3 replicas. Each pod on which node, everything is stored. See, when pod is deleted, update actual state, only 2 pods are running saved in etcd. Trigger reconciliation means the kube control manager constantly read from the etcd and compare desired state and current state. Yes, very good now. So guys, the YAML file information stored into etcd. Let me tell you. The concept is, yeah, see. Okay, I'm saying if pod is deleted, immediately controller will work. but controller take the desired state information is there, right? Desired state means what I want. Current state, what exactly created. This controller, to get a desired state information, request will go to etcd, but not directly through API. Etcd information, when you run a YAML file, right? This information will store into desired state. The replicas are 3. Now desired state are what in the etcd? 3. Current state deleted 1. Desired state, current state both are same? No. When API will monitor always and give information to controller, one pod is deleted. Okay, let me check with etcd. Hey, etcd pod is deleted. What is the desired state? 2. Okay, let me run to maintain control. Understand? But controller won't ask to you, hey, what is the desired state, right? Ask to etcd where the information is stored. Now, state file configuration information, how we can store inside the state file? Here, etcd. How state file will work is controller. Storage is a state file, working process is a controller. Understand? Okay, now question to you. Okay, question to you. Yeah, guys, let me take I'm not explaining YAML file today class. I'll start from tomorrow. Let me understand the just architecture explanation only for today. Yeah. If I take this YAML file, if I run, how many replicas are there? 3 replicas. Right? Copy. So my architecture and replicas in YAML file, how many replicas are there? 3. So when you apply, there is a command, guys, in Kubernetes, kubectl apply -f your YAML file name. You can give any YAML file name. This YAML contains how many replicas? 3. Whenever you can apply, a request will go to API. API will ask to etcd any information is there. If no means, okay, keep it with you 3 replicas. The configuration details, all configuration details, YAML file name and all stored in etcd only. Clear now? Why API will ask here? If you run second time also same YAML file, request will go to etcd. Hey, this pod's already running. Why these persons are running second time? Give information back to no changes. Right or not? But when the information is not there in etcd means what? This requirement is new requirement. Oh, I don't have any information. Maybe this is new requirement. Okay, good. Then let me check with scheduler. New requirement, I need to take a decision from scheduler, right? Which pod, which node and all. Hey, scheduler, 3 replicas. Okay, all nodes availability resources are free. You can go for 2 pods in one worker node, 1 pod in one worker node. Anything is fine. All are free. Okay, then inform to etcd. Hey, etcd, your end 3 replicas are there, na? So scheduler is confirmed that 2 are in this worker node 1, 1 is worker node 2. No. That is different story. That is advanced concepts will come. This is default behavior. So scheduler will decide based on the resource availability. Scheduler will give the information to API, the information pod 1, node 1, pod 2, node 1, pod 1, node 1. This information, JSON information API will give to etcd. Keep with you. Which pod, which node, how many pods and all. Now, why etcd? If something is, any requirement will come, first API will check with etcd, right? etcd information already there. Oh, this is not new requirement, already given before you to me. Right or not? Okay. Then etcd stores the information. API will ask to Kubelet. Okay, as per the scheduler, here two times need to run, here 1 time need to run. Here 2 pods will create, here 1 pod will create. After that, this runtime engine will update to Kubelet, created as you said pod. Kubelet will information to API, created pod. API will information to confirm here. This time is confirm. etcd, whatever information I have given by scheduler, right? This is confirm now. Keep it with you, the information of each pod, each node. Clear now? After that, API will update to control manager also. Now tell me, if I run second time, what will happen? Request will go to where? API. API request will go to where? Second? etcd. What etcd will say? No changes, all are good. If you run third time, fourth time, fifth time, sixth time, no, my end already this configuration stored. No, this is already running. Clear? But if I change 3 to 2 and run again, what will happen? Customer IPS server is saying that customer is asking 2 replicas, but etcd will give no, my end 3 replicas already stored. I think I need to delete one. Okay. Initiate the deletion process. That will take care of API, not etcd. etcd will give information my end 3. Okay. Now API will inform to scheduler, I'm deleting a one pod. Which pod need to delete? Any resources more, that pod I will delete. Scheduler will give, or scheduler is not giving any response, means API will inform to kubelet, delete any one of the pod. After delete again update. After delete again API will update etcd, deleted. And again controller. Understand? Controller check with etcd. Whenever 2 replicas are there, right? It will update 2, right? Now desired state is 2 or 3? 2. Desired state updated or not in the etcd? Updated. So if any one pod deleted, again controller request will go to etcd. Desired state, what is the desired state? 2. Okay, my end 1 only current state. Okay, let me run one more time. Now current state will update to desired state. Clear? This is the process. Maybe I'm continuously speaking 1.5 hours, right? Maybe this time not possible to understand 100%. This is just theory. But once we go inside the practicals, 100 to 1000% you can understand. No doubt. If you are able to understand 5% is enough, my end, I'm happy. I'm not expecting from you 105% is enough to take you that level. 1000%. Are you clear? And my suggestion, please don't think how to create etcd and all. My suggestion, day 1 you can take like a day 1 only. Don't think day 20. Okay? How kubelet will run, sir? How? That's what, not how. Why is it today? How we can learn in 20 days, right? 15, 20 days. Clear? Any questions from anyone? No questions, sir. Yes, evening job readiness program, I don't have any information, guys. To whom that, I mean, the process for who can join and all, I don't have even single information. Please don't ping me regarding job readiness program. They requested me to take a job readiness program. I'm going to directly take projects only. I'm not going to explain single concept again. Okay, direct projects. Whether you are able to understand, I don't know. But job readiness program, we can see like a job readiness program. Again, the process will explain, no use. I don't know who can join. I don't know who are eligible this course. I'm completely blank. I can follow like a job readiness program. So maybe you may get a confirmation today who can join also from there, and so we can see today. But little interesting projects I'm planning now. Little difficult projects also at the same time, like Elastic Cache and all. We see what best we can do. Okay, thank you so much. Bye bye.